in last video lecture we had seen effect of substituent on reactivity and orientation of benzene. Let us see effects of substituent on acidity of phenol. So what are the phenols? Phenols are the organic compounds where hydroxyl group is attached to benzene ring. Okay, and phenol shows the acidic character. Why? Because there is a removal of the hydrogen from the hydroxyl group to form the phenoxide ion. Okay, so the phenols lose the hydrogen atom from the hydroxyl group and there is a formation of the phenoxide ion. Okay, so this phenoxide ion has the unique properties. First, the phenoxide ion is well established due to the resonance. Second, the oxygen which is attached to the sp2 carbon which has a high electronegativity. So the carbon will pull the electron from the oxygen. This makes the phenoxide ion stable due to the distribution of the electronegative charge, and phenol readily loses hydrogen ion and shows the acidic character. Okay. Resonance effect creates the positive charge on the oxygen atom in phenol, weakening the oxygen and hydrogen bond and allowing the proton to be released. Okay, so deprotonation of phenol initiates the formation of phenoxide and phenate ions which also exist as resonance. Okay, so there is a phenoxide ion. This is the phenoxide ion where there is a formation of the several resonating structures. Because of the distribution of the negative charge which is present on the oxygen atom, it migrates over the ring, benzene ring, and there is a formation of the several resonating structures. Okay, as a result the resonance stabilizes both phenyl and phenoxy ions due to the delocalization of the negative charge over the benzene ring, and this phenoxide ion is more stable than the phenol. Okay. However, if any substituent attached to the benzene ring, stability of the phenoxide ion will be affected. So, if any electron donating group is attached to the phenol, these groups pulls the electrons over the negatively charged oxygen, and thus the stability of the phenoxide ion reduces and resultantly the acidity reduces. Okay, so due to this reason the Crysol is less acidic than phenol. Okay, so in Crysol there is a methyl group which is attached on the phenol, and this methyl group is electron donating group. Due to this, the electron density over the negatively charged oxygen will increase and thus makes the more increase in electrons over the hydroxyl group, and thus the Crysol is less acidic than the phenol. Okay, and so all these are the resonating structures of the orthocrysol. Okay, so orthocrysol is less acidic than that of the meta and paracrysol. Why? Because this methyl group which is attached to the phenol, that is in crysol, which is very nearer to the anion which is formed after the removal of the hydrogen from the hydroxyl group. Okay, and this destabilizes the group, that is structure. Okay, understood? Thus the acidity of the phenol is like this. The phenol is more acidic than metacrysol, then para, and then orthocrysol. So orthocrysol is least acidic than that of the meta and paracrysol. Okay, understood? If electron withdrawing groups are attached on phenol, then these groups pulls the electrons from the negatively charged oxygen, and hence the stability of the phenoxide ion increases, also increases the acidity of the phenoxide ion. Hence orthonitrophenol is more acidic than the phenol. Okay, so this orthonitrophenol pulls the electron from the hydroxyl group by the inductive effect and the resonance effect, which had been seen in last video lecture. Okay, so these are the resonating structures of the paranitrophenol, where there is a extra resonating structure which has been shown by the paranitrophenol. Then why the paranitrophenol is more acidic than the orthonitrophenol? Because in orthonitrophenol there is a intramolecular hydrogen bonding. Because of this, the orthonitrophenol cannot easily donate the proton, but in paranitrophenol the hydrogen is free, and so the paranitrophenol can easily donate the proton, and hence paranitrophenol is more acidic than the orthonitrophenol. Okay, understood? we see that the para-nitrophenol has an additional resonance structure where the negative charge is delocalized on the oxygen of the nitro group, which are highly electronegative, and hence they stabilize the charge effectively. This stabilization is not possible in the meta-nitrophenol because there is no opportunity via resonance for delocalization onto the nitro group. Okay, and this nitro group at meta position withdraws the electrons by the weaker inductive effect. Hence, ortho and para-nitrophenol are more acidic than the meta-nitrophenol. These are the structures of 2,4-dinitrophenol. Okay, so as the number of nitro group attached on the phenol increases, the acidity of the phenol increases. The order of acidity of the phenol is like this. So 2,4,6-dinitrophenol is more acidic than 2,4-dinitrophenol, and which is more acidic than 4-nitrophenol, that is this is the para-nitrophenol, and which is more acidic than 2-nitrophenol, that is the ortho-nitrophenol, and which is more acidic than the phenol. So okay, understood? Okay, thank you.